So first of all, welcome to reInvent and Vegas. So our session today is about supply chain in automotive, and we will cover some of the challenges in this area. With me, there are two other speakers from IBM, Orem Alibran, and from Toyota Innovation, Travis Washington. And our rough talk will be around 45 minutes. We'll see how we do on the time side. This will be without questions, but if you guys want to ask us some questions, I think we'll meet you in the backstage or outside. Here is a rough agenda for today's talk. Mostly we'll talk on the challenges supply chain landscape is having, and then we see the cost of the disruption. And then I will come back after or speak on these first 2 points about how we have done the solutioning for this, the logical architecture, the physical architecture, and the services, AWS services behind it. And then most important one is the Toyota's case study, which Travis will cover. And then there are a few call to action, and I have like 3 recommended sessions which all of you should attend. And with that, ladies and gentlemen, please welcome Orem Alibran from IBM.
Thank you, Parminder. Good afternoon, everyone. My name is Jorge Malibran, and I'm a senior partner with IBM Consulting, where I lead the US automotive industry. Automotive is a fascinating industry. At least for the last 20 years, it's an industry that has been undergoing continuous disruption and transformation, from electrification to focusing on mobility services to more recently, autonomous driving. But let's spend a couple of minutes discussing the challenges that the industry is facing. The first one is increased product complexity. As consumers, we never had more choices than today to choose a vehicle and buy a vehicle. From hybrid models to more accessories, just in the last 5 years, the number of vehicle configurations has doubled. And that puts a lot of pressure on automotive supply chains. Second challenge, it's higher customer expectations. So we are all very familiar with the Amazon one-click buy on how easy it is to order a Lyft or an Uber ride, and we expect the same experiences, the same transparency when we interact with automotive companies. And that becomes a challenge and an incredible source of pressure for companies. The third is tariffs. Definitely top of mind for all executives. Just in 2025, the top 6 automotive manufacturers had to reduce their profit estimate by over 25 billion because of tariffs. And finally, is supply chain disruptions, from strikes in the port to chip shortages to natural disasters. The industry has been plagued with this supply chain disruption that are affecting both the P&L and the customer experience. These 4 challenges are adding tremendous pressure to automotive organizations, and disruption is pervasive. 94% of all companies have been affected by supply chain disruptions. And that's affecting their P&Ls, and more importantly, is affecting the experience of their customers. From increased logistics and transportation costs, from missed deliveries, delayed launches, lost revenue. All that is affecting your experience when buying a car and is pushing the vehicle price to an all-time high. Just in September, for the first time ever, the average transaction price of a new vehicle in the US was over $50,000. And that's creating a big affordability issue for automotive companies. So why does this disruption happen? First, it's because it's a very complex process. The supply chain from order to delivery becomes really complicated in global organizations like automotive companies. So I'll briefly describe the process end to end so you understand a little bit of the challenges that automotive companies have. Starting with ordering. If you are in the market for a new vehicle, probably you go online, you go to the company's website, look for your configuration, maybe go to the dealer, do a test drive, With some luck, the vehicle that you want is in the lot. Most of the times will not be there, and you'll have to place an order. That order then goes to a scheduler. This is a very complex process where automotive companies will have to optimize capacity, transportation cost, which plants are available, what's the ideal estimated time of arrival for the vehicle to the customer and to the dealer. That's a very complex process in itself. Then is the manufacturing process. In plants, sometimes overseas, with really old legacy PLM technologies, probably not as connected as they should with the rest of the systems, becomes also a very isolated process. After the build is done, then is the quality checks. That's also a very manual process where people will go, inspect the vehicle, review it, sometimes just write down with pen and paper what's happening to that vehicle. Then transportation. Third-party transportation, sometimes these vehicles have to be shipped on a boat, on a ship, then go to a train, go to a truck. Very complex process too, and multiple parties, independent organizations, go through it. Pre-delivery inspection. They want to make sure that the vehicle is in perfect condition before it arrives to the dealer. Again, a very manual and siloed process. And finally, delivery at the dealer. That's where you're going to get your vehicle. And really important to know, that's also a third party. That's data and systems and different companies completely independent from the automotive organizations. So, given that that's the process, what are the different challenges that companies see when trying to optimize that whole journey? Number one, disconnected processes. You saw the 7 stages before. Each of those stages is supported by different systems that they operate independently, that they don't share as much information as they should between them, with manual processes in between where every exception requires someone to jump in and make a decision. Of course, multiple data challenges. Different systems, some of them really old. The data is not consistent, they have different standards. The language that the logistics team or the manufacturing team use are very different. Even the data models between them don't align. That becomes a very difficult problem to integrate all these data models. Then legacy technology. Some of these systems were built probably 20, 30 years ago. Some of them out of support. Some of them don't connect with the new technologies. They don't have any AI. They don't go to the cloud. They operate in silos just because they were built 20 years ago. And finally, processing bottlenecks. So some of these processes are manual, file-based. There's a lot of focus on batch processes, which makes this whole end-to-end journey very slow. You can imagine that if there's a logistics issue, maybe that data is not uploaded until the end of the day, then the transportation team gets it the next day, but they have to change something. They will not put it in the system until the following day. By the time it gets to the customer, there's hours or even days that have passed and no one has acted on it. So how do we solve that? So in this presentation, we'll discuss how we are solving this for automotive companies and more concretely for Toyota. But there's 4 things that we always keep in mind. Number 1 is we always aim for real-time processing. We want to create real-time event-driven platforms that as soon as something happens, we can act on it. Second, it's unified end-to-end. There's a seamless integration of processes and data from the beginning, the ordering, to the delivery, and everything, everywhere in between. Fourth is AI power. We put AI at the core of every process. We try to automate whatever we can automate. We try to create this idea of the human in the loop, where humans are there just to manage exceptions, but everything else should be part of the system. And finally, it's customer-centric. Everything we do has to translate in value to the customer, into a better experience, into making sure they get the vehicle faster, or they find it at the right time, in the right place, for a much optimized customer experience. And with that, I will hand it over to Parminder to discuss how we do it with AWS.
Thank you. Okay, folks, we have seen some of the challenges and costs of disruption. So let's dissect first the conceptual architecture, and then I will go over the physical architecture. As you have seen that mostly the challenge with any system is around the data, right? So data is always somewhere scattered in various functions, in regions, on-prem, ERP, non-ERP system. So in this case, the data was in the mainframe, and our first job was to get that data offloaded from mainframe to the AWS cloud. Now, how do you do that? So there is a golden standard when it comes down to replication of the data from the mainframe, which is CDC, right? So you don't want to run your query against the mainframe system live because it will adversely affect the performance of the mainframe. So that is why you use the CDC, the sidecar journal, where you get the change log entry and then replicate that piece. The second way to get the data into the AWS cloud is through some SFTP offline batch process, right, overnight or hourly. When you get those two legs from real time and as well as the batch process, it has to go to some messaging system. And that is where you can get all the events stored as a stream. And once you have the stream, the next logical point is like, how do you store the data using the polyglot storage? What I mean by polyglot is raw files from the flat files, right? Structured, semi-structured data. You also need to think about the databases in terms of like the SQL and the data product in the data mart. So you need to take consideration of all types of the data which will land. And then, of course, the backbone of the transformation is the data mesh layer, the data fabric. You need to think about how you're going to store the business logic somewhere else rather than in the same code where your main business logic is, right? So if the rules engine has to be separate from the business rule, the event processor is also important. Don't think just about the success path, but always the exception path too, the retry logic, what we sometimes say, like if something fails to write it into the Kafka stream, like how you will have a different store for the retrial. The data lineage piece, if you ever want to do some root cause analysis and the lineage for some audit purposes, you need to make sure that also is accounted for. Of course, like when the events are coming in at rapid pace, right, you have to put that into a canonical model. So various canonical model here is like year make model, right, the trim for the vehicle, the dealers, the parts from the supplier, the whole order system. So you have to think about those domain stores too. Now, how do you make sure the data which is there can be exposed to the downstream application? So you have to think about the REST API. You need to think about like how the PubSub model also can be employed here for the exposure of the data. Now, apart from that, some functions, some line of business will like to do a search. So for that insight into the data, you have to make sure enterprise search is also enabled. And what are those downstream applications? So downstream applications can be another line of business application, which is calling your exposed event data, right? So which you are capturing, so internal customers of yours. So you need to think about the workflow enablement for those line of business applications. The data science, the data engineers want to consume your data. So you need to think about whole machine learning, the feature engineering, the inferencing part. Apart from, if there was any exception in the upstream, you want to have some notification and alert for the exception management, right? So the right team has to be alerted about that. So this is sort of like your conceptual. And what goes behind, of course, the operation and governance, the standard thing. You probably have seen it like billion number of times, the standard way to get the observability and security, identity and all that. But once you have this conceptual, what happens is like, you need to then think about the AWS services which will be employed. Now, what you see on the left side is still the on-prem. Those to think about like a national processing center, the port processing center, the national vehicle system. Some of this data will be there in the ERP application and as well as in the dealer management system and all that, right? So how do you get the data first into the cloud is using the data migration service. And data migration service is what will capture the CDC capture from the mainframe and put it into the Aurora database. So you land the data first into the Aurora database, and then subsequently the second path is the SFTP process, right? The secured file transfer. And both of them will ultimately lead to the Kafka. And this will be registered as a topic for the downstream application to pick. Now, what you see with the managed service Kafka is like for the regionalistic purposes, you will have the different regions and different high availability on all that. But it is like a stateless transformation. It's just like a pub subtopic, right? But what if you have to actually enrich the data? So you have to use something with Flink, right, which runs on the ECS container. And then what I was saying earlier about the rules engine separate from the business layer, that is for the maintainability of the code. If you want to change some rules, that should be segregated from the main Flink application. Data quality, of course, like team is using the data buck here, but you have to use any product around that. All of this data which is coming in are the event. Event is the vehicles event. An example of that is like when you manufacture a vehicle, it goes through a life cycle journey, right? That life cycle journey is like vehicle is built, vehicle is now in yard, vehicle is now at the rail, vehicle is now at the truck. So it will have those events life cycle. And then those events are getting captured when the vehicle journey is moving from one leg to the second leg. So these events are coming in at rapid pace. So what team has done is we are storing each of the current event inside the MongoDB, and there is elastic cache behind that, if, to improve the performance. But apart from that, if you see on the top, all the older events are getting stored inside the DynamoDB for the, the data lineage, or if you ever have to do some root cause analysis or what happened to that event. So those old events are, all the event history are stored in DynamoDB. And the reporting purposes, the data is again stored into the Amazon Aurora for the downstream application to do the dashboard reporting and all. The S3 is again for the life cycle of the data. You have to use life cycle policy in the S3, and you have to go through that whole life cycle policy to optimize the cost so that you don't consume, always the best of the latency which Amazon S3, some of the tiers give. Apart from that, think about using this data via API. But if you guys are familiar with the graph query language, so AppSync is used for running the graph query languages against the MongoDB, right? So if you think about all of the event in a list, that is the wrong way to look. But if you have to think about like a graph, the hierarchical, so you need to use something like graph query language, which is supported by the AppSync. Again, you can actually use the, Kafka to write the pub/sub topics for the downstream application for messaging. If some downstream application want to use the system like that. For the B2B scenario, if there is another line of business inside your organization or even outside, you can use the API gateway to expose the data. So all of this probably will land either in some kind of like a dashboard reporting like QuickSight or Tableau. That those are one set of consumers, but there would be a different set of consumer who are your mobile app or your dealer application app. They also need a API exposure of this data. Now, the third community who might use this data is your data scientist and data engineer, whole training and inferencing play there, right? So this covers the AWS services, the physical architecture. What goes next is the whole machine learning, what the people in our team have done. The standard way to do the feature engineering is using the Amazon SageMaker. But before Amazon SageMaker can do any of the feature engineering, you have to land the data in some sort of storage. So all those events which are coming in, they are actually stored into the database, as well as the like semi-structured, unstructured data is also inside the S3. Like If there is like a vehicle planning or some shipping planning thing, that also can be used for the feature engineering. So as a data engineer, some of you are probably come from that background. You know what happens before you actually do the model training is the whole EDA, the exploratory data analysis. So what happens inside is like you have to scale the data, or you need to remove the null value or the outliers and all, right? So for that, Wrangler, SageMaker Wrangler is being used here. Once you complete the cleansing the data and sanitizing and removing the outliers and all that, you make it available for the applications, the engineers to do the feature engineering, where you do some of the PCA component analysis to find the right set of the features for your inferencing task, right? So it's all about the training. And then the training piece is a standard slides, which you guys have seen it. But what is important here, the key takeaway is like there are some inbuilt out of the box machine learning model. If you want to use, you can bring your own too, but you can have the processing job either take your own or out of the box. And the previous slide too, I forgot to mention even some of the things like scaling of the data and then the removing the null value. There is out of the box transformer available. Now the algorithm which is used in the forecasting comes under the regression and time series, basically time series calculation, right? So ADA boost, XG boost, those are the standard algorithm apart from random forest and all. So those also are inbuilt, but you can also bring your own. Once the training process is finished, so you will come up with a candidate model. But before you reach to the candidate model, you will run your machine learning model with a various set of permutation and combination, hyperparameter tuning, and all that, right? And then you can actually have a side-by-side comparison of the various run of the model training. Now, there is one important feature inside SageMaker during the training process, something called as like instance recommender. So what it means is like you, instead of running this for various permutation combination, you can actually use this instance recommender and it will save you a cycle during the training. So that is the most important key takeaway from this, apart from the standard stuff, how to do the feature engineering and selecting the candidate model. So typical MLOps, you have to think about like how you can do the whole code pipeline, who have the access to this, the identity, like the people who are actually taking the models from the dev to QA, they are different and all. And there is something called like a batch transform, very useful in the cases where actually you want to pre-train and pre-inference. So you can have the training and inferencing done before. And what team has also done in this case is like every 4 hours, they actually do the inferencing and they keep the data ready. And then that is what is actually giving us the near real term. It's a near real term because there is a little bit of calculation, but if you actually do the inferencing every 4 hours, you are almost ready for the next event to come in. Next event is again checked. And if it matches, it uses that score. But if not, then it does the inferencing part. The drift in the model, so model Amazon SageMaker Model Monitor is the one which checks for the drift. It's very important to have this kind of stuff because if someone is using one model and he done some changes, so you want to have some alert and notification to the other people who are taking care of those operations of the model, right? Like if there is like a below threshold or above threshold some things, then you can have that alert and notification to the team. So this, the way this works is like once the model is trained, candidate model is picked, and it is registered in the SageMaker. During the inferencing, when the event come, it triggers a inferencing task. So in that, you will have the vehicle event which is coming in, as well as some of the shipping plan which is associated with that event. What it does is like it triggers the inferencing for that. But before it does the actual inferencing, it will check what batch transform job has already done it, like every 4 hours. it's a pre-processed and all it is kept. So it does a check. If it finds the match, it will use that. Otherwise, like what happens during the inferencing is like, as I was saying, like the vehicle has a journey, right? It is order, manufactured, put on the yard, rail, truck, dealership. So each of this leg, what inferencing does is like it calculates the actual estimated time of arrival to that node. And each node's time is calculated and then it is aggregated and then the ETA for that vehicle at dealership is calculated. And that is the whole brain behind it. But in very simplistic terms, this is like a regression thing, right? But apart from the regression to get the actual days, like vehicle will arrive in 7 days, the last mile calculation is also uses the classification. And classification in the terms like whether the vehicle will be a 1 day late or a 2 day late or 3 day late. So there is a little bit of, apart from regression and time series forecasting, little bit of classification things also going on here. And of course, like once you have the ETA for that particular VIN or vehicle identification number, you actually store that ETA time for that vehicle in the database so that your downstream application can consume it, and there is a lambda in between to trigger that. With that, I think you guys probably should welcome Travis Washington, who has been working on this project from last 3 years, and he's from Toyota.
Thank you, my friend. Thank you. Thank you for the warm welcome. It's a pleasure and an honor to be here to speak to you about Toyota and our case. One of the things before we get started with the case and everything, there's a few things that I believe is very, very important. We have a lot of smart people, a lot of innovative people, committed people, right? And that's all great and good. But one of the things that's essential to help bringing this all together is systems can be complex, challenging, but people put this whole thing together. Meaning, even though we're studying AI, even though we're doing machine learning, all those things are very important. But if you don't have the people that's in sync and unified for the same goal and purpose, then all this is really for naught. So I say that to say that with the presentation here and what we're talking about, a good measure of success is not only what you produce outside in terms of a product, but also how the people come together and work for a collective purpose and goal. Now, I know that wasn't necessarily reflected on the slides, but that's something that's key. These are key elements for success. And I think we all want to be successful in ways of how we can be successful. So I'll go forward now. So here, in the dynamics, the digital supply chain twin, they did a great job of explaining all the challenges, the steps, the things that we're doing and have been doing and constantly doing to improve, right? And here's some of the things that we deal with that are important elements. We have what we call manufacturing plants, we have ports, and we have rail yards, or some people call that truck away points. These are different paths along the way in the logistics pipeline from order to delivery, and we'll dig into that. We have unique transit links, right? We have some numbers there, about 1,200 there. We have possible vehicle journeys, where a vehicle, depending on its home, just like we all come from somewhere, we all traveled somewhere to be here. Well, you came from somewhere to make it to this point, right? Some may have came from California, some may have come from New York, some may have come from right up the street here in Vegas, right? They all have a journey to get here. As we're here, we all have a journey to get here. Our journeys and our paths may not be the same. Our time and duration may not take the same, right? So we have to be sensitive to the customer, which our customers, what we're saying is the dealer, but even the actual customer, the final customer, which is you and I that drives the Toyota product, right? So, and then network graphs, digital twin for entire logistics networks. So here, we talked about the business case. One of the things about Toyota in this business case that we have, I'm part of a group that's called digital innovation, and we're looking to transform or to move not just our systems off our legacy systems, right? That's one aspect of it. But if you're just moving from one platform to another, I mean, you can give that as a check mark, but are we innovating? Are we being transformative? Are we looking to meet the customer's demand, right? And those are the questions that we need to ask. And those are the questions that we try to answer. So in doing so in this business case, as you see here, we try to look at the shipping journey, right? In that, we try to look at and say, okay, look, what are some key milestones that take place in the supply chain, right? We look at things at time of build or when the construction of the vehicle. We look at the quality effort that takes place. And here in the build, we say, hey, that could take from one day to maybe a couple of days, right? Here, the quality, we're saying, hey, this should take X amount of time. In this case, we have about 0.5 days. We say, hey, when things begin to ship or begin planted in the yard to be shipped, ready to be shipped, hey, that can take up to 2 days. And here we're saying the shipping transportation. Now again, as we mentioned earlier, you come from different places and different backgrounds and different places to arrive to this place. Some of you may have taken a few hours to get here, maybe 4 hours. Some of you may have taken 5 hours, 6 hours. Some of you may have taken a day to get here. That's part of your transportation move or your logistics move. And then the final destination, or what I like to call the dealer. Just like you have a home, right? You have an address. That's your destination, right? The dealer is just that way. That's the destination to us. We want to know, how do you get to your home? How can we help get to your home and get it there efficiently, safely, but also with quality? And then we have factors affecting our delivery, right? This is where we have challenges, but at the same time, take into account the number of vehicles at each leg, right? Because as we all travel here, if some of us came from New York, maybe 5 of us came from New York, and we're on the same plane or different planes, right? So the number of vehicles at each leg is important. The number of vehicles in transit, actually in motion, that has shipped, that's on its way to the destination. And we'll see it in the next slide about different potential, I won't call it stops, but transportation points, right? The day of the week comes into play. Sometimes the day of the week matters. Sometimes our dealers may be closed on a Sunday. Maybe they open, right? That may have an impact on the final delivery, right? Weekend closures, as I just mentioned there. Route stability and index. That's really important for us. We like to know the path that a vehicle is expected to take, and we have that based on what we call a plan or what we call a shipment plan. Based on that, that's very important for us, but also that our partners, which is our carriers, be able to perform and execute those things. And then we have carrier capacity, right? This is where our partners have a capacity on their movement of vehicles and the transportation of vehicles. You can't take all the vehicles at once, right? You may take a certain number of vehicles on a rail car. Maybe you take 10, 12 units on a rail car. On a truck bed, you may take maybe about 14, right? There's a capacity there, but there's also capacity going to its destination. Those are very key factors there. Also, business challenges. Our certainty for arrival time, right? Toyota, for the longest, ETAs or dealer ETAs, we call it ETAs is estimate time of arrival, but we take pride in that, of trying to understand when is a vehicle supposed to get to its destination. How accurate are we in doing that? How good are we, how bad are we? We try to keep it as realistic as possible, meaning we don't want to sugarcoat it, we don't want to inflate it, but at the same time, we want to see where we are, because in doing so, that gives you a chance to improve. There's always constant improvement. If you think you've arrived, then at that point, most likely you haven't, and something's going to pass you by anyway. So we're always looking to improve. We're always looking to get better, right? And then we had challenges for poor visibility for our customers. As I mentioned earlier, as we say the dealers are our customers, that's just one of our customers. It is a very important customer, right? But also you are potential customers as well that goes to those dealerships, whether you buy online, you buy the vehicle, you walk into a dealership. We want to be able to provide a tool and a method and credibility and stability where our dealers can share this information with those customers, right? We're part of that responsibility. That's part of our responsibility, right? And then target outcome. We want accuracy, confidence scores, right? Here's we measure KPIs where we look to say, okay, what is our accuracy? How good are we? How bad are we? How can we get better, as I mentioned earlier? Duration window ETA, right? What's the size of our window? We do predictions, we have a window, we have a start date and an end date. We try to keep that tight, right? But there's times where we're further up in the pipeline, we're not as tight. But we're working on that. We're working on that and improving that, where we're trying to improve and reduce our window size, but keep a high accuracy. This is a challenge. Data science comes in, it's a challenge, right? We have to see how our models are performing, but not just our models performing, but how have we performed historically, right? So those things are coming into play. And then replacement vehicles. This is where the opportunity where we can have a vehicle that may have had some type of delay, right? And maybe a customer has a need to want that vehicle a little bit sooner. Maybe they can do some type of swap or change or replacement vehicle. But to give that type of flexibility to our customer, in the case the dealer, that can share that with the end customer. All right, so what I'm showing you here, it says delivery of a customer-centric supply chain. One of the things that's super, super, super important for us is keeping the customer first. We want to keep the customer first. The reason why we want to keep the customer first is because the customer is essential to what we do. Again, we can build systems and all that, but we have to be able to keep our customer and what they see and what they experience in part of our solutions and part of our how we do things. So as you see here, this is a picture of what we call call vehicle pipeline, right? I'm just going to explain a few attributes and then I'll get over there. If you see here that we have, some people like to call this a pizza tracker, but we have various milestones. Up the top, we have it with just some high-level information that's important to the vehicle. The VIN, the make, the model, the year of the vehicle. If you see on schedule, that's what we call an ETA status, where we try to identify the status, whether something's on time, whether it's at risk, whether it's delayed, right? We try to keep track of that. We measure that based on what our original ETA is and what that progressive ETA continues to update. So we have an original ETA and we say, hey, look, okay, we predicted originally, I'll make up something. We originally predicted something from January 10th to January 15th, okay? And that's our original starting window, right? What we try to do is say, hey, look, we also do calculations along the way. If you notice here that in this pipeline, these are various opportunities where we may trigger an ETA. In doing so, we try to see if we're still on schedule as it moves through the pipeline. If it's not on schedule, then we try to flag that up. Again, we try to be realistic with ourselves, we're realistic with our customers, right? In doing so, we have information that's tied to the vehicle details history, ETA history, and documents. I'm not gonna touch on that too much. And then we have what we call our life cycle statuses and things of that nature, and then just a description of what's going on. Here in these milestones you see, customer configuration, submitted, production confirmation, build, processing, rail departure, rail interchange. You see that arrive and departure, and then arrival, and then on truck for delivery, and arrival at dealership. This is something that we try to give visibility to our customers, right? And people who's working with our dealers as well, right? So they can see the progression of where things are, right? Some people are very nitty-gritty and they like this. Some people say, hey, you don't even tell me all that. Just tell me when my vehicle's gonna get there, right? So we understand that we have multiple customers and multiple views, but regardless, we wanna be consistent, whether they're looking at things from the time of production confirmation, or they're looking to say, hey, a vehicle is expected to rail depart on December 8th, did it happen or not? Some people want to know that information, very detailed. Some people say, I don't care about that. Just tell me, when is that vehicle gonna get there, right? And this fulfills all of that, right? And these are milestones that we've identified, and these are unique to the vehicle, meaning this vehicle, when this vehicle is built, this vehicle came into our Los Angeles port or Long Beach port, okay? There's an import unit, okay, that came from, most likely from Japan, okay? Now, with this unit, this is the path it takes. Let's say it's going to a dealer in, Las Vegas here, somewhere in Las Vegas. Well, this is the path it might have taken. Maybe we have a vehicle that's going out to somewhere in Colorado. It may have a different path. So each vehicle has its unique path. And the reason why we do this is because we're trying to be customer-centric, right? each customer, just like you all came here, have a different path to get here. Now, some may be very common, but some may be different, right? So in doing so, we build this, what we call journey map, and this journey map is tied to each vehicle, right? And in doing so, we have what we call estimates and actuals. Our estimates is based on what we use. It's two things we do with that. Our estimates is based on predictions that we use via data science, right? And we try to predict when that milestone is supposed to occur, right? So we take that into account to say, hey, the rail departure is scheduled to happen December 8th, right? And in doing so, we're able to predict, hey, this vehicle should get there per prediction on December 24th, right? In doing so, we use data science, we use modeling, and look to do predictions. Now, I'll go ahead and I'll just reference some of the data elements on the bottom and then the 4 decks on the side and the 4 points on the side. We have other information that we try to keep track of, right? When the vehicle is supposed to be built, when the vehicle is going to be wholesale, when the vehicle's first use. And these are just some data elements. These are not all the data elements, but the point is, in addition to giving the prediction, we want to give the experience. So you know about that vehicle. That customer knows about that vehicle. He knows what's going on with it. He knows where it's built. He knows where it's shipped. He knows where it's estimated. He knows when it actually happened. He knows if there's going to be some delay. He knows if his ETA is on schedule or not. So these are try to make it personalized for the customer. We have a full-scale design system, and it's used tailored experiences and personalized views and tools. And then we have reusable components. Business outcomes. We try to optimize schedules and prioritization, enhance ETA analytics, right? We try to enhance proactive rerouting and end-to-end predictive visibility, right? That's what we're trying to do. That's what we're trying to do, right? And we're doing it. It's just that I shouldn't say trying. That's what we are doing, and that's what we'll continue to do, and that's what we'll continue to get better and better and better. We have to stay hungry. If we don't stay hungry, you'll get satisfied and you think you've conquered it all. And as we know, this world is very dynamic. You know, people want things, they want things now. They want information, they want more information now. If they don't get it from you, you're gonna get it from someone else, right? So we learn to look at our data, analyze our data. My manager, his name is Smel Haddad. He says this term, I think he came up with the term, I believe he did. He said, you know, find your data, access your data, and trust your data, right? That's his thing he says to us sometimes. And I agree with him in the sense of we have to be intimate with our data. We have to get to know our data, right? Yes, data can be challenging. We can have hiccups and things of that nature. But at the same time, we can understand our data so then it becomes more predictable, more reliable for machine learning, right? And those are key elements. The more variability you have, man, the more challenging it's going to be, right? Some may require data quality, as we talked about earlier, right? These are all key components. These are all key components to bring this whole thing together, right? And so I just wanted to touch on that. So here we want to try to give you guys a demo. So if you see to the right there, we have an AI chat agent, chatbot. Says, can you tell me the current status for the ETA? Oh, it's going to move it pretty fast, sure. Sure thing, the ETA status of the, oh. Sorry about that, went kind of fast there. So here on this, on the checking the status of the VIN, one of the things that we had a challenge with, as you're looking at this, one of the things we had a challenge with is understanding our ETA status and kind of where things are, right? And one of the things we came up with AI chat agent is to say, hey, be able to tell us where's the status of our vehicle, where's the progression of our vehicle, right? And in doing so, one of the things we came up with is an ETA status chatbot agent here. Okay, all right. One more thing here and I'll get ready to turn it back. One of the things here at Toyota, and I'm grateful to be at this company. I think it's a great company. I think is one of the best companies in the world. They always emphasize whether you're an employee, whether you're a partner, whether you're there for a short period of time or you're a long timer, right? Always have the respect for people and always try to dig into people's talents. Why do I say that? Because in doing so, you can create things like this. You can create things where it has value to someone, in this case to our customers, right? But in doing so, there's the human aspect of it and there's the system aspect of it. Today we focus mostly on the system aspect of it. But please don't take for granted the human aspect in the role that you all play in your respective organizations. And I know we in Toyota, we take that very highly and very seriously. And we're proud of it. Not boastful, we're proud of it. And those are some of the pillar foundations that we have. Okay, moving towards agentic AI experience. Here we have what we call a Cube Assist agent. Here, we want to talk about instant supply chain visibility, proactive delay detection, and then smart alternative vehicle replacement, and then human in the loop decision making. We talked about this a little bit earlier, right? So here's where we're going, right? Here's where we are and here's where we're going, right? Again, we're not trying to be satisfied. We're not trying to say we arrived at the mountaintop, but at the same time, we're pushing and trying to make the bar higher and higher and higher, right? And hopefully this is beneficial to you guys. So with that, I'll get ready to turn it back to Praminda.
Okay, so how this was possible, like nowadays you guys have heard a lot of things about agentic AI and everyone wants to build like next agents. So what you saw in the previous slide was somewhat, using the AWS services. Think of like two things, right? Like if you're breaking down your current code, think of that one component as an orchestrator agent. And then the agent for the ETA calculation, the agent which goes and check the national port processing system or national vehicle system, those can be your agent. And when your orchestrator agent is talking with those multi-agent, you can use A2A protocol. But then if you have to use some internal knowledge base and the database, think of using the MCP server for that, right? So the team, when they started agentifying this solution, it was roughly like 4 or 5 months back. And that time we didn't release what is called as agent core. Nowadays, like 2 weeks back, we released. So that is this architecture. But team right now is working on the agent core and they will start using the runtime, observability, identity and all that. But the basic plumbing of those things are in place. And what will happen with using by using agent core now is that earlier, like if you remember, we were saying like use the Anthropic model and the Nova model out of Bedrock. But with the agent core, you can use any model, OpenAI or even your own built model. You can use any framework like CrewAI or Agno. You can use any protocol. Like earlier we said like we'll use only MCP server, but now A2A is inbuilt. So what you are not seeing in this slide is the whole agent core. But team is actually working on it. And I'm sure some of you have the need for this type of solution. So what you saw today was like the use case for the automotive supply chain. But you can extend this to retail CPG, for energy utility, the processing, the chemical processing transfer. The core of this was built on the Toyota's vision, the relentless vision to satisfy the customer's satisfaction on delivery of the vehicle. Because owning a vehicle is probably second most expensive thing which we'll have. First one sometimes will be house, but your dream vehicle, you place the order, you want to know when it is arriving, when I will get that. So that was the ultimate outcome which Toyota wanted. And then that was supported well with the domain expertise of the IBM because they know how to do the supply chain from their domain expertise over decades, 20 or 30 years. And this was also possible because what we gave IBM and Toyota was a little bit of a launch pad, and we said like, go build your rocket, because we give length and breadth of our AWS services, but we bet on our partners and our customer to use that and then build the next rocket. With that, I think you guys should attend this 3 session. The last one is a chalk talk, a little different from this one, but it is also around the supply chain. The first 2 are like a workshop if you guys want to use your developer expertise. So I recommend that session. And the second one is again a breakout on that. With that, I think we are almost done. And this is without question and answer. But we can take question and answer on the sideline, as I said earlier. I'm very active on the LinkedIn too. If you guys want to drop me a message next week after you go from here, and IBM, if you guys have your use cases where we can help, please let us know. And when we can help, and we can come out wherever you guys are based out of, and then we can give that knowledge, like how this system was built, the 3 years of work which team did. And some of them are sitting in the second row, Ramesh and team. Please take them for a coffee. They will tell you a thing or two which we could not cover here, but they are the domain expert. They have built this system from last 3 years, right around the COVID. But thanks for coming. Thanks for listening to us.